Problem number 20. So you just have to figure out which functions are not differentiable at x equals 0. Knowing how to graph is very helpful. We can see that 1 is differentiable at x equals 0 because if you know the graph, you know it's nice and smooth right there when x is 0. For number 2, if you don't remember the graph, which I don't always remember that graph, I can easily find y prime. So y prime is 2/3 x to the negative 1/3, and therefore we're going to have y prime at 0 does not exist because you can't take 0 to the negative 1/3 power. So that's a DNE. So that didn't say there was only one answer, so let's keep going. Part 3 here says y is x to the 4/3, so y prime would be 4/3 x to the 1/3, and that does exist. Okay. So it can't be 1, it can't be 3. For number 4, I already know that's already y equals 1 over x squared, and that graph I'm familiar with. It just looks like this. We know that it comes down like this, and so it's not even defined at x equals 0, so it can't be differentiable at x equals 0. It's not even continuous, so that's also an answer. And then for number 5 here, we've got that y is equal to a piecewise function. It's equal to the sine of 2x when x is greater than or equal to 0, and it's, y equals, let me put that minus sign back in there, the opposite of the sine of 2x for x values less than 0. Well, if I take the derivative from the right, I get 2 cosine 2x for the x values greater than or equal to 0. I wouldn't write all this if I was doing it myself. And then it would be negative 2 cosine of 2x for x values that are less than 0. Therefore, y prime at 0 of the top piece would be 2 times cosine of 0 is 1, so 2 for the x values that are, so the right-hand derivative would be 2, and the left-hand derivative would be negative 2. So therefore, since the right and left-hand derivatives don't equal each other, we say that that function does not exist, or that function is not differentiable at x equals 0.